Hello and welcome to my individual screencast of my project LectureLink for the course TDD27, where I, with my lab partner Elias, did a connection style game. I think I'm gonna start within the root of the application, the main, and so we use this. The app is wrapped in the strict mode to help to catch potential problems during development. And we use the Auth0 package to manage the user logins. And the domain and the client ID, which connects to the Auth0 instance, works at the moment, but if we were to release this to the public, we would probably need to have some sort of protection, or like, for example, .env file or something. And then we have this cache location, and this allows us to stay logged in even if the player refreshes the page. And because earlier when you were logged in and you refreshed, you get logged out. So it was quite critical for a more smooth application. We then have the home page, and in the app ESX, we have the routing. So we use the React router, specifically the browser router and the routes and route, to define which of the components are used in to define which components are used for each URL path. So the LectureLink is the home page, and match histories for player stats or similar to player stats. And it made the app very modular and scalable. And also, when developing, it was quite easy to take it step by step by just implementing a new sub page when you started working on something new, like player stats after we were completed with the single player. It was quite easy just to add a new route. I'm now gonna move on to the actual game mechanic, or we can start with how we fetch. So we use certain words and categories in this game, as was shown in demo. So this hook, use fetch words, it's designed to fetch the daily set of words for categories, or to fetch to the multiplayer. So we generate 4 random IDs that is used to identify the IDs in the DB or the Firestore, because each category has a ID, 1 to how many you want. So, and we only fetch, and then depending on which generated numbers we generated, we can then fetch those certain category IDs from the DB. And then use them in the multiplayer and single player game logic. So we have this use game logic. It handles many of the core gameplay logic for the single player, such as managing tile selection and callback when a game ends, etc. So and it's designed to separate some logic from the UI, which keeps the component single player game board somewhat clean and focused on rendering only. So in this function, shuffle words, we take all the words and firstly we flatten them into an array of words and category objects, and then shuffle them randomly so that the grid looks differently each time. We have this category colors. Just when you complete a category, each history, math, fruits, they get a different color on the left-hand side when in single player, not in multiplayer. We have this handle tile click. So if selected tile is already selected, we deselect it. And also, like, it checks if we have selected 4 categories or selected 4 tiles, we check if it's a correct category. So this function checks if all the if the 4 selected tiles are a correct match. So we check if all the if the categories belong to the same category, or the same, or if all the words belong to the same category. We then have some and then we check if all the categories are confirmed after the update. And if it was a wrong guess, or if it was a successful guess, we update the game. And if it was a wrong guess, we then increment the new tries. So you have only 4 tries in single and unlimited in multi at the moment. So if you were to, for example, have a wrong answer 5 times, it would exceed the max tries or equal to, and it will end the game in a loss. And this is used later on in the single player. And so we can move on to the single player. So it's where the main function is actually the handled game end. So where the main logic of the game ends happens. So and basically it updates the player stats if you win or lose, and it shows a pop-up. So we want to do prevent duplicate calls, and then we mark the game as finished if it is finished, a loss or a win, as I explained earlier. We determine if the player wins, and by retrieving the max tries. And we get the today and the weekly date from the date FNS library, which made it very nice to actually check. So we checked the Firestore if the current date that the player is playing on is already existing, and if it is, we increment. And if it doesn't, if the date, if he has already played the date, we don't increment, of course. And yeah, and basically for the same thing, so for the weekly and for the daily, we update a win once per day. And then we have this, and also, so when you, we had this problem where in single player you could refresh the page and you get new categories. So you could cheat by that, by just refreshing until you get a better layout. So we store the categories locally, and then we pass this on to the single player as props, so the handle game end and the categories. So the single player game board is primarily focused on just assembling and rendering the components that make up the single player game. What actual game logic happens in the use game logic and single player. And then, so we can go over to how the multiplayer works, or some parts of it. We can start with the join room. So we have this in Firestore, we created these rooms, as we showed in the demo, where we where 2 players can join a room and battle it out in a game. And in this room we store certain things, such as how many, for example, during the game, how many categories each player has completed at a certain point, and who the player is, and if the room is full. We also store later. Okay, I will explain this later on, but we also store the certain words for that room. But yeah, so we just check if the user is authenticated. No, if it is if the room is ready, and then we just if the room doesn't exist, we try to create a new one, and so we store the players, the name and the number of categories solved, which start at 0 and then gets incremented when they pick a correct category. And as I explained, it's similar to the single player, but we also save the categories so that we can keep track of, so that they don't can get duplicate of a certain category. But if the room exists, so either players in it or 2 players, we check if there's a spot open, and if not, it's full. So and then we have just this use effect to sync the game state in real time from the Firestore to retrieve certain things, such as if the player ID and such, and how many players. We have a leave room, which works similar to the one in the multiplayer game board, but I will go to that one instead. And then, as well as we did in the single player, we pass the props down to the multiplayer game board. So I'm sending like data, like categories and the game state, and functions such as the set game state, so that the child component has everything it needs to run the actual game. We can begin with the multiplayer game board. So we have this shuffle array which uses the Thomas algorithm, I don't quite remember his last name, to shuffle the array, which is used in this set shuffle if needed. So basically we want to shuffle a tile if it at the game start, and if it doesn't have been shuffled. So we flatten the tile objects, and then we shuffle them randomly using this shuffle array, and then we and this is just to ensure that that both of the players see the same shuffle tiles, because we wanted that's what our thinking was at least. We then have this a similar handle tile click, but we needed some different mechanics for this one, so it's a bit different from the single player ones. So if a tile has been selected, or we can deselect a tile, and we also add a clicked word to the selection. So basically clicking toggles the selection as earlier explained, and clicking for if click for selected words, it will check for a category match, and it will reward points depending on if it's a correct category. And we then check if all the 4 tiles belong to the same category. And we also have this to prevent double scoring in the DB or in the Firebase later on. And then we want to get both get the player and the update to their solved count on the room ID, so that we can keep track of how the game is going. And then we just what am I saying? So we save this categories that's now completed by the player, and we visually separate the match categories from the rest. And then we try to update the room on in the game's Firestore section. We then have the leave room mef function, which is quite big, but it needed to be that way because we have a lot of the player's stats and data is created here. So we only want to run the game only want to run this function if a player is authenticated and in a valid room. And also if the game isn't ready yet, you can leave. So basically if, let's say I play against player X and player X DCs, his internet goes out, then I can, then I'm able to leave the room and maybe join a new room. And it will also delete the room afterwards. And also if I join a solo room, it will delete it. And also, we will identify from the room, we can identify who won and lost. And we can then start to build like the winner's match history. So we will increment the wins, and then we will merge this with the existing data. And we didn't want duplicates, we had some problem with that, so we had to merge it. And it's the same mechanic for the loser ID, so we increment that certain user number. And so that you either get a loss. So in the Firestore, on the users, on the user document, each player has listed its previous matches. So it will partially update that and also update the loss or the win number. And then we try to then only like, so we delete the room if you're the winner. So the loser can leave the room and the room still exists, but when the leaver leaves, it will be deleted. And then we have these tiles, which are just when we want to reorder the tile grid, so that when like player 1 has already so the categories that the player 1 has already solved appeared at the very top. So it makes it easier to keep track of the progress. And we're only doing this when needed, so use memo was very nice to avoid extra work in that regard. And yeah, that was everything for the multiplayer. Yeah, and then we send both some of the props to the multiplayer tile grid and the single player tile grid of the single player. So basically, once a category is solved by a player, all its tile will become confirmed. And instead of showing like the actual words, it displays the category name in the multiplayer. So our thinking was somewhat like, in the single player, we can have like just at the very left, like what category it was. But we were thinking if it's a multiplayer game, maybe you want it to be more clear that it's showing. And in the single player, and both multiplayer and the single player take use the common tile grid. So it also uses the common tile grid, but filters out the tiles that have already been matched and / or confirmed. So each confirmed tile is tracked individually, not like by the full category like in multiplayer. So if a tile is matched, it's filtered out and not shown. I can then move on to the player stats. So I can begin with the multiplayer stats. So we fetch the user and we look how many wins and losses he got from the leave room when the game ended. And then we calculate certain metrics such as how many games, win rate, and computed rank score, which is just losses versus wins minus losses. And from this we can then determine the rank. And we just and also we also retrieve the daily in the multiplayer, we also take use of the data FNS to update the certain player, so that when you get a win, we update the daily wins of that player, so that he can, I got on the 5th of May I got 5 wins. And we also push up this rank then to the Firestore. So basically we get the daily wins and we sort them by the date, and then we can then display them in a line chart. Single stats work similarly, but it uses, instead of the daily wins, we retrieve the weekly wins, so that we can have week to week how many wins you had each week. And we have similar calculations here. We also, in single play when you select 4 words that are wrong, you will get an error or a try, as we explained earlier, and where the maximum was 4. So we push that we store that in the Firestore after each game, and we can then display this, so that, and we take the amount of errors through the games played, so you get a % of the error rate. And leaderboard is just, we retrieve the users and their rank, and we display them in the leaderboard as the 4 different cards. And depending on what rank you have, you will end up differently in the leaderboard. And also you get a rank number that is minus wins minus losses, that is used to determine your certain rank in this bracket. So if you have 10 wins and 7 losses, you will end up in bronze, but if you have 10 wins and 3 losses, you will end up in silver, because that's 7 and between 10 and 5. And lastly, we have the match history. So we fetch the user and the user's document, and on that user we have the matches. We have all the match histories for that certain user, so all the previous matches that he has faced. We then group the matches by the components, so Johan and etc. has an identifying card. On top of the screen we have the search bar where you can filter out certain opponents, so I can search for Johan. Basically Johan 123 will be filtered out from Johan 234. And then we have these player cards, so when you start match history you get all the previous matches, or all the previous opponents that you have, and all of these opponents have its own player card, where we display the wins loss, the win rate against a certain player firstly, and then we have below that. So Johan, I have won 3, lost 4 against him, and I have a win rate of and then below that play card we have the match list, so we list all the matches that you can scroll through with CSS. And there we just so we have if it is a win or a loss, and then we just the date of that certain match, and also we also store on the match history the number of categories sold for that certain user. I can actually show you. So basically if I go to users and I go to my account here, we can see that if we look at the very end, For example, against Godkväll at Telia.com, I lost severely, and he got 4 solves and I got 0. But in another match, when I won against Test 34 at Test.com, I got a win and he got 0 categories solved before the game ended. And yeah, that was everything from me. Thanks.